From the Brenna Bunker in the quarantined Piedmont of the southeastern United States, this is Ace Academy's 7th grade science. Good morning, 7th graders! This is your first broadcast from the Brenna Bunker besides the intro I gave the other day. So this is a little new for you guys. 8th grade's been getting this for a little bit. So, here we go. So we got new unit, new subdivision of 7.P.2. So we got 7.P.2.4. And we're talking about simple machines. So our I can statements. I can illustrate examples of the types of simple machines. So, first thing we got to figure out is, all right, what is a simple machine? A simple machine is a mechanical device that changes the direction or magnitude of a force. A mechanical that changes the direction or magnitude of a force. So if I push the table, force is that way, that thing goes that way. Well, now a simple machine is something that I use to change the direction or magnitude of the force I'm using. So if I'm pushing this way on this thing, I'm just pushing on it. So, but if I built something to kind of help me amplify the force I'm using to be able to do something easier, so that's the whole point of a simple machine. Is it something that makes the job easier by lessening the amount of force you got to use to do something? Well, what kind of simple machines are there? You say, oh, well, there's a bunch. So there's 6 that we're going to go through right today. So the first one is a lever. Yeah, I've heard of a lever, haven't I? Well, a lever is a beam pivoted at a fixed point called a fulcrum. There's a word you need to know. There's a word you need to know. You need to know what a lever is. This is the definition. A beam pivoted at a fixed point called a fulcrum. So if you imagine a seesaw, you got a dude over here and you got a dude over here, right? Person. The fulcrum is at the point where this thing is doing this. Now this guy happens to be a lot heavier and he's like, I'm going down with a force, and then the force over here goes up. This is what we call a class 1 lever. So a class 1 lever is basically evidenced by a seesaw where the fulcrum is in between what we call the effort and then the resistance. So those are the terms you're going to be hearing. Effort. We're just calling it the force applied by a person. And then the resistance is the object or load you are trying to move. So the effort is the force applied by the person, and the resistance is the object or load you are trying to move. So I'm pushing down this side of the teeter-totter. This side's going up, lifting up the resistance is here, and the effort is here. So this is a class 1, where the fulcrum is between the effort and the resistance. So if there's a class 1, that means there's got to be what? A couple more classes, right? So everybody's got this written down. If you don't, rewind. I'm erasing on the next thing. Now we hit class 2. Now, the resistance is between the effort and the fulcrum. So, if I've got an object that looks like this, this is a class 2. If you imagine the fulcrum here being a wheel and this being a big bucket, what does that look like? Looks like a wheelbarrow, doesn't it? But, so the fulcrum's here. The effort, you're lifting up on the handles of the wheelbarrow to carry the load that's between you and the fulcrum, which is the front wheel. That is a class 2 lever. The resistance is between the effort and the fulcrum. The resistance is between the effort and the fulcrum.